Let us start developing the next circuit, sequential circuit called latch. So as per the definition, sequential circuits depends upon the present input as well as the past outputs. So there should be some memory or the storage element in between the input and the output. Hence the sequential circuits depends upon the present input as well as the past outputs. So it consists of clock signals so that it will be triggered using the clock and synchronized with other digital circuits. So let us design a simple latch. So this is the basic latch design. So it consists of D as an input. I given an example D latch, clock input, clear is nothing but reset, and Q bar as per the flip-flop. So the concept of D latch is nothing but the output will be latched or triggered whenever there is a clock high pulse comes over the way, otherwise it won't be triggered. That's all. When there is a clock pulse, that is the clock level is high, then the input will be triggered, else the input will not be triggered. Latches are level sensitive, which means it works at only the logical high or logical low of the clock input. So as per this design, I create the code now for your references. So I declare clock and clear as input now. So as per the design, D also input. So we can declare D also in the same line. Q and Q bar is the output. Q bar is nothing but the complement of Q. So here we are developing only the functional architecture of the system. Hence we no need to bother about the Q bar. So it is obviously the complement of Q. So I directly writing the code with Q. So I create a process and I am naming the process as latch. Whenever there is a reset, that is the clear is being 1, then the entire latch should be goes to 0. So the previous value of Q should also be goes to the default value called 0. Any other default value also you can provide, or the previous state also can be assigned. So this is the syntax for latch. So my previous value is Q equal to 0. I am ending the process and 2 times I am ending the if statement. So if it is rising or falling edge of the clock, we use VLSIF instead of VLSIF. So here we are looking for only the trigger value, that is the clock should be completely high or completely low. So I am making it as VLSIF clock equal to 1. I am ending the process. So now I simulate the code and show you the output. This steps should be practiced. You have to open the waveform window, everything. Clock should be right click and give clock since we are doing only simulation. Clear should be right click, force to 1. Normally active high reset only we use. D should be forced to any value because D we only going to trigger. So slowly we can make the trigger. So I am making clear to 0 now, then only the reset will work, the latch will work now. So it is waiting for the clock to change. So now we apply D equal to 1, so that at every time when the clock level goes to high, it waits for the D value. So whenever D goes to low or high, whatever changes happening in the D, that will be transferred to the Q only if the clock is completely high. So that's the difference we want to view here. So Q bar we not yet assigned anything, so it is coming as a red line. So here you can view whether it is triggering properly. So whenever the clock is completely high, then only you are getting the trigger value, and it wait for the next trigger to come. Until that the clock will be, that is the Q will follows the same value. So as per this diagram, so the same thing happens, only till clock high the D will be transferred to Q until the next clock comes, that will follows. So that's the simple design of latch. And coming to data flow diagram, a simple diagram you can see that looks like a latch. So that's all the RTL code for latch and realization of latch with the simulation of MODELSIM.